This is Patty LeBlanc, your teacher. I would like to spend some time today by means of this video to share some of my ideas about the key points regarding the two chapters on validity and reliability in your text. I felt like there's a lot of math there, and some of you may be getting panic-stricken, and so it seemed important to me to provide a summary of what I feel are the key ideas, and also to help you prepare for your exams, your quizzes. The key questions in assessment are validity and reliability. Validity asks, does this test measure what it's supposed to measure? And reliability asks, does this test or instrument consistently measure what it's supposed to measure? These are two definitions you need to really emphasize. Next slide. Reliability. Let's start with that. It's the harder of the two concepts, and every semester I struggle with, am I really going to cover this? Because it doesn't really apply to classroom teachers or classroom-based tests very often. But I really think it's important for you at least to have a conceptual understanding of reliability. So I'm going to endeavor to help provide that conceptual understanding. Reliability may refer to a complete test or to individual items on the test. Reliability, as we learned in the previous slide, has to do with consistency of measurement. When a test is given multiple times to the same individual, or the same test is given over and over to different individuals, those measurements are taken and averaged so that there can be a determination of the consistency of the measurement. It is not really a big application in classroom-based teaching. We really don't have time to give a test over and over again to the same person to see if it's a reliable instrument or not. It is, however, a very serious concern for standardized high-stakes tests. In order to get an estimate of reliability, you typically have to involve a large number of students to gain accurate scores. And these large number of students are sampled across the nation for these high-stakes tests, like the SAT, the GRE, the GMAT, the LSAT, and so forth. Okay? Here you'll see in this slide some examples from industry. XYZ parachutes open reliably, consistently, in 999 out of 1,000 trials. I don't want to be the one trial that doesn't open, but you get the point. Consistency is really important in manufacturing as well. The third item there, this tool reliably produced drill bits that are exactly 5/8 inch long in 2 million trials. You can see that industry is very concerned with reliability. Next slide. In education, we're concerned with reliability primarily with, again, our standardized test. For example, this test reliably differentiates between those who have mastered the material and those who have not. That's important. This personality test, for example, reliably separates the sheep from the goats in your classroom. This rubric is a reliable measure of writing skills as evidenced by inter-rater reliability. Several different raters used this rubric on the same writing sample and got very similar or consistent measures. That's inter-rater reliability. Okay? The reality about reliability is it is not truly a serious consideration in classroom-based testing because we don't have time to re-administer a test to the same subjects or conduct the sophisticated mathematical analyses that are required to get a reliability coefficient. Validity is the more important concept for classroom-based tests. So, how do you determine the reliability of a test? Let's say we're ETS, Educational Testing Service, and we have SAT and GRE and LSAT and so forth. How do those people determine the reliability of a test? Well, they take multiple measures of a test to determine the consistency and then mathematically express that consistency as a number between 0 and 1. The higher the number, the greater the reliability or consistency. The general rule of thumb for educational testing, and really in any of the social sciences, is that standardized tests, such as these high-stakes tests, should have reliability ratings of 0.80 or better. In educational testing that is usually high stakes, there are three main methods that reliability is determined, and these are discussed in your textbook, but I wanted to reiterate and simplify for you. Stability reliability, alternate forms reliability, and internal consistency. Okay? Stability reliability, also known as test, retest, just what the name implies. It has to do with whether or not an instrument is stable over time. A test or subtest is given to the same subjects with a period of time in between, sometimes a month, sometimes a year, sometimes several years. The two scores on the test are correlated mathematically to yield a reliability score between 0 and 1. The higher the score, the greater the reliability over time. IQ, for example, is a very stable construct, unless there's been a brain injury or something like that. So one would expect to get the same score on an IQ test, plus or minus a few points, even after a period of a number of years have elapsed. Most of the time, it is not really feasible to give the same instrument to the same subjects again and again in classroom-based testing. So do we use this very often? No, but high-stakes test makers do. Okay. There's also a methodology called alternate forms reliability, also known as equivalent forms. Alternate forms are developed by test makers to measure the same concepts, skills, constructs, traits, etc. Large number of students are given alternate forms. For example, the students in Texas might get Form A, while the students in Arizona get Form B. Both forms are measuring the same things for the same age or grade level. The scores for the groups taking the alternate forms are correlated to get a score between 0 and 1. The higher the score, the greater the reliability. So alternate forms, while we might do it occasionally in classroom-based testing, it's not used typically because we don't have a lot of time to be developing alternate forms of the same test to test the same skills and constructs. Split half reliability or internal consistency reliability we might use in a classroom as a method for testing reliability. One has to make sure when you use this methodology that the test that you designed has at least two equivalent halves covering the same content. So you would have to have at least two items covering the very same content and so that you could split that test in half. Basically, you give the test having half the students answer the odd-numbered items, half the students the even-numbered items. Then you correlate the scores for the two groups and express that number as a number between 0 and 1 to get the reliability or consistency score. The higher the score, the greater the reliability. Okay, let's talk a little bit about the relationship between validity and reliability. It's kind of an anomaly, and it's sometimes difficult to remember, but I hope this will help you. A test may be reliable, but it can still not be valid. However, if a test is valid, it will be reliable. Here's an example. You have a thermometer at the butcher store, and it is measuring temperature inside a certain refrigerator that keeps meat. Every day at the butcher shop, it consistently measures temperature. And as far as the butcher's concerned, it's consistently measuring temperature in the right, appropriate way. However, the food inspector comes in, he uses his thermometer and realizes that your thermometer is actually consistently measuring things at 5 degrees less than is actually measured. Therefore, it is a consistent measure, but it is not a valid one because the thermometer may be defective. So, use that as a little reminder, a mnemonic to help you remember about this relationship between reliability and validity. If you have a test that you're looking at, thinking of adopting at a school, in a school system, for example, and there's a high validity score, 0.90 or better, and a low reliability score, there's something wrong. If a test is valid, it will also be reliable. Here's some examples from education. Let's say we use a learning styles questionnaire that consistently groups students into 3 different types of learners: auditory, visual, or kinesthetic. If the groupings, however, have no basis in the actual learning styles of students, the test is not accurate or valid. We can reasonably assume that it's therefore not reliable either. If the test is valid, however, we can reasonably assume that it will consistently group students as well.